10 permutation 4, because we've got 10 numbers and we want 4 of them in order, and that will also say 5040. So any of those are acceptable ways to use your calculator, and remember that you're allowed to use your calculator on the AP exam. Okay. A psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick a first, second, and third activity? Now notice order matters because they're saying stuff like first, second, and third. It matters which one comes first, which one comes second, which one comes third. So there are 8 activities. We care about order, and we're getting 3 of them. 8 permutation 3. Remember that on your calculator, if you want to repeat the same action, you can just hit second enter. I don't know if I've taught you guys that yet. And then I'm just going to change that to an 8. And then a 3. 8 permutation 3 is 336. That's how many different ways. You can just pick the first 3 activities, but remember, order matters. So, or I could have said 8 factorial divided by 5 factorial, because that's 8 minus 3, which is also 336. Or I could have done, let's see, it'd be 8 times 7 times 6, 336. So lots of different ways to do the same problem. Now, there's also a formula called the distinguishable permutations formula, and that's where you've got some things that are indistinguishable from each other. So let's say you've got a subdivision, and you've got 6 one-story houses you have to do. So it's like one street. 4 two-story houses and 2 split-level houses. How many distinguishable ways can the houses be rearranged or arranged? So, okay, let's just make up an example. Let's say I've got like a little short house, and got like a split level here, and here's a 2-story house, and another 2-story house, and then a couple more of these 1-story, and another big one, and then a split one, and then a small one, and then a tall one, and then a small one. Let's see, I've got 6 little ones, 4 2-story houses, those are these, and 2 split level houses right there. Remember, you can always pause. Now, the point, when it says indistinguishable from each other, what they're trying to say is that, like, these little ones, if I took this house and I swapped it with that house, it would look the same because they're both 1-story houses. This is a boring, like, cul-de-sac community, so every house looks exactly the same. So the distinguishable permutations formula is n factorial on top, where n is how many different total things you have, and then n sub 1 factorial on the bottom, n sub 2 factorial, n sub 3 factorial, etc. Where n is your total choices, and then n sub 1 are like all how many are in each different kind. So these are like the different kinds. Okay, so if I was going to go back to do this problem, I would take 12 factorial, is it 12? Let's see, 6 plus 4 plus 2 is 12. Do I have 12 in my picture? I do. 12 houses on the top total. That's my big total. And then on the bottom, first I'm going to look at, I've got 6 1-story houses. I've got 4 2-story houses and 2 split-level houses. So those are all like my different kinds that I'm dividing by. When you put this in your calculator, this one doesn't have like a fast thing like a permutation or a combination, so make sure you put parentheses around it. So go ahead and stop for a moment, pause the video, and use your calculator to do the same thing I'm doing and see if you get the same answer as I do. Make sure you use parentheses. Okay, 12 factorial divided by parentheses 6 factorial times 4 factorial times 2 factorial is 13,860 different ways. I think this example's in the book, so I'm going to see if I got that right. Yep. Okay. I'm so sorry that this is overwhelming. It's a lot of probability very, very fast, but you can do it because you're amazing. All right, you're going to try example 8 and pause the video and see if you can do it. It's also a distinguishable permutation one. So you're going to have to come up with your own formula and then put it in your calculator. All right, so the contractor, I'm assuming you paused. If you didn't pause, pause. Contractor wants to plant 6 oak trees, 9 maple trees, and 5 poplar trees among the subdivision street. The trees are to be spaced evenly, and how many distinguishable ways can they be planted? These problems are really obvious because they have literally the word distinguishable in them. So 6 plus 9 plus 5, that is what? 15, 20. 20 factorial on top, divided by all the different kinds. We've got 6 oak trees and 9 maple trees and 5 poplar trees, and then you got to make sure to put parentheses around those. I'm just going to go in my handy dandy calculator and hit second enter. Brings back the last thing I typed. I'm just going to change these numbers so I don't have to go back and find that factorial button every time. 6, 9, and 5. Oops. Still had to do it anyway. Ugh. All right, let's try again. Fine. All right, 20 factorial. Divided by, what was it, 6? Six, 9, and 5. Okay, that's a lot of ways. Glad we didn't make a factor tree for that, or a tree diagram. I put my comma in the wrong place. So 77,597,520 different ways. Yikes. A combination is, let's see, how did I write the last one? An ordered arrangement of